Yesterday, we looked at graphing your cosine and sine functions when you had vertical and horizontal stretches and transformations that required also translations. Today, what I'm going to do is just a couple more examples, and I wanted to get this on video for you guys rather than doing this live because I want you guys to be able to go back and play it again and again if you need some further assistance. Okay, so first thing that we need to do, as we did yesterday, is we need to rewrite this so that the transformation or the operation that's connected with your theta, when you type it in your calculator to check or in Desmos to check, remember that needs to change to an X if you are checking it. We need to take apart that 1/4. So that 1/4 is going to come outside and we're going to be left with theta in the middle. And then remember, if we are undoing distribution, really we're dividing. But the only thing is we're dividing by 1/4. And so when you go about changing this, if you're dividing by 1/4, that's the same as multiplying by 4. So that means that this is going to change to an 8 pi over 3. And then the -1 is going to be attached to the end. Now, guys, one of the things that I would recommend is just take a second and distribute this back in to make sure that you do get what's in the parentheses, okay? Which you do. I already checked it out. We are good. And so we can go ahead now and we can go ahead and plot this. And so when you look at this, let me go ahead and take just a minute and plot out for you the original cosine function. Okay, so the original cosine function starts at 1, and then it's going to end at 1 when you get to 2 pi. Halfway in between is where it goes to -1, and then halfway in between here and here is where your x-intercepts are going to be. So that is your parent function. Now, what we are going to do is we're going to do this in 2 steps. And the first step, if we're doing order of operations, is we want to deal with the things that are being multiplied. So this is going to be telling us that we're going to be vertically stretched by a factor of 2. This is telling us that it's going to be horizontally stretched because remember, you're thinking opposite. So yes, that looks like divided by 4, but really we're going to be horizontally stretched by a factor of 4. And then I'm going to do that first, okay? So what that tells me is here, instead of up 1, I'm going to be up 2. And then here, instead of being over 1 pi unit, I'm going to go ahead and actually stretch that to 4 pi. So it's going to be over here, but again, instead of going down 1, we're going down 2. And then from here, I'm going to go ahead and take that 2 pi, stretch it all the way to 8 pi, but again, I'm going to go up 2. Now, something to keep in mind at this point, and this is kind of how I do it. I actually don't do it when I'm doing my answer keys and whatnot the way I just showed you. What I do is I go ahead and do this first one, okay, because it doesn't go left or right any different. All we're doing is changing the amount that it goes up. And then I go ahead and I say, okay, because my original period is 2 pi and it's been stretched by a factor of 4, I know my new period, or excuse me, my new start over point is 8 pi instead of 2 pi. Halfway between that is my minimum. Halfway between that are my x-intercepts. So that's going to be at 2 and 6 pi. So I kind of just cut things in half to kind of get my framework. Now, what we're going to do then to finish is we're going to go ahead and do our translations. And if we notice here, this is telling us that we're going left. And what I'm going to do is I'm going to recommend, and you can do however you want. My brain works better in mixed numbers when I'm graphing. So I'm going to say that this is 2 2/3 pi. And then this is down 1. And so what I'm going to do is I'm going to just kind of sketch my new, what I would call like my new x-axis. Okay, so that midline going through that curve is going to be down 1. And then I'm just going to move all of my key points. So I'm going to go ahead and move this almost 3 pi because 2 2/3 is almost. So I'm going 1, 2, and almost 3 pi, and then I'm going down 1. And then, so this is my new point here. And then I'm going to go ahead and do that to my other x-intercept. So I'm going to move this 6 pi, almost 3 units, and down 1. And so those are my new x-intercepts. And then I can do the same thing with this point. I'm going to move it almost 3 and down 1. And then I'm going to do it to this point, almost 3. 1, 2, almost 3, down 1. And that's going to be my new point there. And so now if I'm looking, I'm going to just darken these up with blue just so you can see the points because I kind of put some points on my graph when I was counting. So just to make that clear, it's going to look something like this. Okay, and I can keep going if I wanted. I could say, well, I know that in my original graph, or excuse me, in my green, Oh, sorry, in my red, I got lost on my colors for a second. In my red, from y-intercept to y-intercept is, or excuse me, x-intercept to x-intercept is 4 pi. So I could say here, this is just after 3 pi, which means my next one, I'm going to add 4 pi because my period hasn't changed. And I can go ahead and kind of continue that if I wanted to continue out and use that the whole period of the whole function is 8 pi. The gaps in between those x-intercepts are 4 pi. Okay, so again, guys, I apologize. I kind of lost track of my colors there for a second, kind of had a little brain lapse. But you could keep going and kind of using that pattern, all right? So let's go ahead and take a look real quick. I just want to show you guys what this looks like when you check your work. So when you look at this, you've got your original here. You can kind of check that this midline here going through the middle is going to be the same. You can kind of check your x-intercepts here just to make sure that those are the same. One of the things to be mindful of, though, is I went ahead and I changed my settings in Desmos, and you can do this in your calculator as well. What I would recommend, I'm sorry, let me go ahead and come over here and click this with my mouse instead of my pointer because it thinks that I'm writing. I went ahead and I changed my horizontal steps or my horizontal increments to pi. And then I also just changed my y-axis so I could see it a little bit better. So usually the default is -10 and 10. I changed that so I could see things just a little bit easier, okay? But the big thing is changing that step to pi to make it a little bit easier to look at. So let's go ahead and take a look at the second one. The second one here is a sine function. Okay, so the very first thing that we want to do is we want to go ahead and rewrite this. So we have y equals 2 plus 1/2 times sine. And then in my parentheses, I'm going to pull that 4 out, make that a theta minus. And again, if I undo distribution, I'm actually dividing by 4 to get my new value that's going here. And so that's going to become pi over 8. And again, if you want to, or what I would recommend is go ahead and distribute just to check, okay? And it will work. And here's the deal. We're going to go ahead. I'm going to plot the parent function in blue just to start. So it's sine. So this one is starting at 0. It's going to reset at 2 pi. And then the halfway point is my other x-intercept. And then we're going up 1 and down 1 within that. Okay? And so then when you look at this, you've got your vertical and horizontal stretches going on. So here, this is telling me that it's been vertically stretched by 1/2 or compressed by 1/2. This is telling me it's been horizontally compressed by 4, okay, or 1/4 if you are thinking multiplication. So either divide by 4 or multiply by 1/4. And so when you look at this, guys, this is going to get a little bit intense, okay, because our units here are pi across the x-axis. What this is telling me is, and this is going to get really, really tiny, and what I would encourage you on your homework is I would change your x-axes, but just to kind of show you how crazy this is going to get, instead of your period being 2 pi, my new period is 2 pi over 4 because, again, it's horizontally compressed by 1/4. So 2 pi over 4 is going to simplify to be pi over 2. So what that means is from my starting point to my ending point, I've only gone pi over 2. So here, that's the halfway mark at pi over 4. And then it's vertically compressed. So instead of going up 1, I'm going up 1/2 and down 1/2. So it's super, super, super tiny. This is my parent function after I've gone ahead and done my vertical and horizontal stretch. So tiny, right? Kind of ridiculous. So then we can go ahead and do our vertical and horizontal translations. So remember, we could tag this +2 on down at the end if it makes more sense to us, but it's gone up 2 and it's gone right pi over 8, which in our graph, pi over 8 is super, super tiny. So what I'm going to do is, okay, think about this. I'm going to go up 2. So this is my new kind of midline of my graph. If I'm going right pi over 8, that tells me I'm going to take this point, my original x-intercept, and I'm just going to bump it ever so slightly, okay? It's even smaller than that, but for the sake of you guys being able to see that, I just want to show it there. And then remember, this is going to restart pi over 2 later, so it's going to restart right about here. And then I can go ahead, my midway point is here, and then I'm going up 1/2, down 1/2, and so that first graph, that first cycle looks something like that. And then I can go ahead and I could actually do another one. I could go ahead and plot another one out and then up and down 1/2, and it's going to look like that. Okay, so again, if you second guess yourself on these, feel free to check your work on Desmos, okay? Or your graphing calculator, whichever one you're more comfortable with. So if you look at Desmos, let me go ahead and shut off the one that we did a second ago so you can actually see this one. This was my original. So I'm going to turn that one off and turn this one on. And you can see here those graphs, how quickly they go up and down and how narrow they are and how short they are. They look like what we just did in green. Okay. Again, if I were you on your homework, I would change this horizontal axis. Instead of going up by like 1 pi, I would maybe go up by pi over 2 or something like that, just to give yourselves a little bit more space to graph. But at least you guys have some examples now on video that you can go back. So just kind of recap, kind of plot your parent function, at least give yourself some points to look at. Do your vertical and horizontal stretches or compressions first, then do your translations, okay? As always, guys, you're going to have time to practice, but please, please, please be asking questions. Thanks.